In order to multiply this problem, we're going to have to distribute the root 18 to 4 root 6 and to root 20. So we'll start off by factoring everything. So we're going to do root 18 times 4 root 6. So I'm looking at these two sets of factors that I've done. And I'm looking for pairs. So I have 2 3's right here, and I have 2 2's right here, which means I'll be taking out 1 3 and 1 2, and I already have this 4 out here. So out in front I have 4 times 3 times 2, which is going to be 24. The only thing that's left underneath the radical is this 3 right here that I did not circle. So it's 24 root 3. Then I distribute the root 18 to the root 20, and I look at these pairs here. And so when I look at those, I have a pair of 3's and I have a pair of 2's. And so I'll take out 3 times 2, which is 6. The negative came from the original problem. And what I still have left are 2 times 5, so root 10. And I don't have like terms, so this is my final answer. Okay, now try this one on your own. And once again, we'll be distributing and so from 3 root 5 times root 10, I have 2 5's and the 3 that was already out there, so 15 root 2. And from 3 root 5 times root 8, I have 2 2's and the 5 and the 2 that are left underneath. Final answer. Here we're going to be distributing root 3 to both parts. And root 2, negative root 2, to both. And so we have root 15 plus 3 root 2 minus root 10 minus 2 root 3. No like terms, nothing else that can be simplified, so that's my final answer. Now with division, remember we don't want radicals in the denominator. So if we're looking at a problem like root 3 over root 6, we can actually make this problem easier by reducing the root 3 and the root 6 since they're both under the radical. So we can start by making that root 1 over root 2. And then to get rid of the denominator, or to get the radical out of the denominator, I'm going to multiply top and bottom by root 2. So root 2 over root 2, because that's equal to 1. So I get root 2, because root 1 times root 2 is root 2, over root 2 times root 2, I have a pair of 2, so just a 2 when I'm finished. Now if we started off with root 3 over root 7, I couldn't simplify like I did in the previous example, so I would just start off by multiplying top and bottom by root 7 over root 7. So in the top I get root 3 times root 7, which is root 21, and in the denominator I have 2 7's, which means the 7 gets out. I cannot reduce the root 21 and the 7 because the 21 is under the radical and the 7 is. Now if we have 5 root 2 over root 3, I'm going to multiply top and bottom by root 3. And when I multiply in the numerator, I'll keep the 5 because that's a coefficient, and root 2 times root 3 is root 6. And in the denominator, the two 3's make 1 3 outside, and I can't reduce 5 and 3 because there's nothing to reduce there, and I can't reduce root 6 and 3 because the root 6 is under the radical and the 3 is not. Now if we have a problem like this, once again, we'll multiply top and bottom by root 2, and in the numerator we get 10 root 10, and in the denominator we have two 2's, so we get a 2. Now, because of the 10 and the 2, I can reduce and I get 5 root 10 for my final answer. Now go ahead and try 6 root 3 over root 12. Hopefully you made this problem easier on yourself by reducing the 3 and the 12 to 1 and 4. So we get 6 over root 4, and the square root of 4 is 2. So it's 6 over 2, or 3. Now go ahead and try 5 root 7 over root 3.